everyone, I'm Mr. Pei. In this video, I'm going to discuss with you the topic regarding KSSM Physics Paper 3. And this is a continuous discussion regarding the experiment to study the relationship between the current and the potential difference of a filament bulb. So this is one of the compulsory experiments in the Form 5 syllabus Chapter 3, Electricity, subtopic of 3.2. If you have already watched my previous video, which is episode 1 regarding the subtopic of ohmic and non-ohmic conductor, you probably already know that how to answer the type of question in Tugasan Amali, berpandu. So in this video, the episode 2 for this experiment, so what are the highlighted part I want to continue to discuss with you in this video? So let us see together. Okay, so firstly, from the previous video, you may know already the type of the experiment. And for this experiment, where we need to find out the phi MV and RV, and then we need to plot a graph. So definitely this is a hypothesis experiment, and I'm going to discuss with you today. Then the second, the type of the question can be classified to two types. From the episode 1, I have already teach you how to answer this type of question where the procedure and diagram is provided in the question. And the second type, which is a non-guided, which is the non-guided practical assignment, EBM we know as the Tugasan Amali, tidak, berpandu, where the procedure and diagram are not going to provided in the question. And I will going to discuss with you in this video. Okay, so the highlighted parts for the part 1 will be, I will teach you how to get the phi MV and RV with the checklist apparatus in the Tugasan Amali, tidak, berpandu. So the procedure and diagram is not provided. So you need to find out your own MV and RV through the apparatus provided and meets the end of the experiment, where will be to find the relationship between the current and potential difference in the filament bulb. Then secondly, for part 1, I will teach you also how to write the correct procedure and how you can get a full mark for your answer for the part 1 of this video, where will be the sample question for paper 3. And then the third will be the 4 terminal rheostat are going to use in this experiment. So in episode 1, so the stimulation are using the rheostat with 3 terminal. So you actually already know how to connect the rheostat, which is in 3 terminal in episode 1. So how about the 4 terminal rheostat? So we do know. So what is the type of the rheostat you are going to use during the paper 3 exam? So you can see here we have the 4 terminal. Top we have 2, and at the bottom we have another 2. So total we have 4 terminal in this rheostat, and I will show you how to connect this type of terminal to the circuit in the simulation. So the second part I want to highlight in this video will be the comparison between the graph of V against I. So where the V will be the potential difference and I will be the current flow through the circuit. And in this video, I'm going to discuss with you the graph where I ask you to plot in I against V. So you can see in episode 1, so the sample question I decided is actually ask the candidate to plot the graph V against I. So the graph will be like this. Okay, if I say you have already watched my episode 1. If not, you may refer back this video in my channel with the link at the corner here. Okay, so this is a sample graph for the I against V, which is a result for this video. So the shape of the graph will be like this. So you can see there is actually a bit different. Okay, so what is the type of the question I'm going to ask with this type of the graph? So will be discussed in the sample question I am designing this video. The first will be V against I. In episode 1 we discussed already. Then in this video, which is episode 2 for this experiment, we will discuss the graph I against V. Okay, then the part 3 will be the last part for this video, which I want to highlight here will be comparison between the effect of the range of current to your graph. So basically it will be like this. Okay, so in my previous video, the episode 1, I give the range for the experiment is between 0.06 to 0.14 ampere, and the shape of the graph is actually like this. And the range of the current provided in the textbook is actually in the range of 0.14 to 0.22. So there are some of the students asking that, so if I say their reading is not in the range where I discussed in episode 1, so what will happen? Okay, so actually this is another set of the data I get in my previous school, so which is at the range of 0.16 to 0.24. So later on, we'll discuss, is there any difference between the different range of the current used in the experiment for your data analysis. So that means we will discuss the graph with low current range, which is in 0.06 to 0.14 ampere, and high current range of the NV, which is between 0.16 to 0.24 ampere, where the data available from me here. Okay, so now let us go to our part 1. Okay, so as usual, this is a common question in paper 3. So the first will be the problem statement, inference, hypothesis, procedure, precaution, and 3 variables will be possible to ask in your question. Okay, and the problem statement, inference, hypothesis, precaution, and the variable, these are questions I'm not going to teach again in this video. Okay, so you may refer back to my previous, you may refer to this video and the link at the corner for the method how you answer this type of question in paper 3. Okay, so I will teach you how to write the procedure. As I mentioned, this is the type of question in Tugasan Amali, tidak, berpandu I'm going to teach you in this video. Okay, and then the others common question in paper 3 will be tabulation, plot a graph, draw your observation, then data analysis, operational definition, deduction, and prediction. Okay, so I will going to discuss with you how to tabulate the data. And actually, I also already discussed in my episode 1. Okay, so that means I will be going very fast for the tabulation. So the detail you may refer again to the video clip in episode 1 for this experiment. Then the plot a graph, also the same, already discussed detail in the previous video. Then the next will be a data analysis question for the graph, where I mentioned that we will be plot I against V in this video. Okay, so the operational definition and prediction will be going to discuss how we answer this side of the common question in paper 3 in this video. So again, the draw of observation, actually you may refer to this video where regarding to Form 4 compulsory experiment on 6.1. So you may refer this video with the link at the corner. And then the deduction will be in this video clip, which is the one of the non-compulsory experiment in electricity also. Okay, so again, you may refer this video link at the corner. Okay, so let us go through the question. So as usual, the first will be the instruction and the list of the apparatus here. Okay, so you are not allowed to work with the apparatus in first 5 minutes. This period is used to check the apparatus list, read the question, and plan your experiment, which is carried out. So mark in the box provided to check the material. Okay, so checklist for the apparatus and material provided will be this. Okay, so you can see again, so we're using filament bulb with holder, battery holder 1, battery. Okay, so for this experiment, I only using one battery, which is same as the experiment you conducted in the compulsory experiment textbook. So for the episode 1, I using 2 battery for my experiment. So you can see what is the difference between using 1 battery and 2 battery for the range of current we are going to measure in this experiment. Okay, so ammeter will be 1, voltmeter will be 1, the connecting wire will be 8, rheostat will be 1, and as mentioned just now, we are going to use 4-terminal rheostat in this video, which is different with the 3-terminal rheostat you have already watched in my episode 1 for this experiment. Okay, and then one switch. So there will be 2 different numbers of quantity for battery, and the type of rheostat are going to use in the experiment, and I will show you in the stimulation later on. Okay, so we have said all the apparatus functioning well with correct quantity. You can just take your checklist. As we discussed in previous video, so the total duration for paper 2 will be 45 minutes, minus 5 minutes for check apparatus, and then you have to straight away read the question and design your experiment, especially for the type of Tugasan Amali, tidak, berpandu. Okay, so you will be left only 40 minutes to conduct experiment and complete your paper 3 question. Okay, so this is the sample question where we'll be asked students to arrange a apparatus and plan your experiment your own. Okay, so you need to find out your MV and RV for this experiment. So the procedure and diagram is not going to be provided for the type of question which is in Amali, tidak, berpandu. Okay, so let us read the question first. So with the use of the apparatus given, plan an experiment to study the relationship of the potential difference across the filament bulb and the current. So the current will be in symbol I. Potential difference will be in symbol V. Okay, so your description should be include the arrangement of the apparatus. So you can see here we have a box. So it's actually you need to draw your arrangement of apparatus in this box provided. Okay, then the procedure of the experiment, which include one method of controlling the manipulated variable and one method of measuring the responding variable. Okay, so here you need to including MV and RV in your procedure. Okay, so what you have to do, see no any procedure and diagram are provided in the question. Okay, so as mentioned just now, procedure and diagram is not provided. So this is the Tugasan Amali, tidak, berpandu. Okay, you need to write procedure and draw diagram, which is here 3 marks. Sometimes will be 4 marks. Okay. Okay, so if let's say you already watched my episode 1 for this experiment, the step is actually almost the same for the preparation step. Okay, so the step 1 here will be you need to identify the MV and RV for the experiment. Okay, so here you can see the first sentence here is actually the end of the experiment, and it's actually request students to study the relationship of the potential difference and the current. So that means here the potential difference and current will be MV or RV here. Okay, so the MV, if I say we already very clear about the experiment, so you must already know the MV here will be current, where you are going to measure by ammeter, and the potential difference will be measured by using the voltmeter. Okay, you are going to measure by using voltmeter, so you have already identified your MV and RV by the end of the experiment provided in the question here. Okay, which is MV is current, RV will be potential difference. Okay, so just now I also emphasized already. So the MV, which is current, will be measured by using ammeter, and then the RV will be voltmeter. Okay, so for hypothesis experiment, okay, so where you actually go through so many compulsory experiment, and in the type of hypothesis, so you should know already, you need to get minimum 5 MV, and then the RV also after we identify the MV. So you need to know what is the range you have to do in your experiment. So here step 2 is sketch arrangement of apparatus which will be relay MV and RV collected. So minimum 5 data needed, just I mentioned already. So for the first, you need to sketch the apparatus and you need to refer to your checklist. Okay, so normally all the apparatus will be going to use that, but sometimes there will be some of the apparatus actually no need to use in the experiment. So you need to justify carefully for this lah. But normally will be all be using. Okay, so here see we want to using ammeter and voltmeter. And the checklist just now we also know already, we have the switch, we have the bulb. So when the bulb is provided, so here we need to connect all the electrical components besides the voltmeter in series. So the voltmeter will be parallel to the circuit. So the others component will be connecting series in circuit lah. Okay. So after you compare the checklist apparatus provided, so you have to roughly draft the diagram. Okay, you can actually draft and the question first before you draw the actual diagram. Okay, so as I mentioned just now, so the battery is provided 1, so here will be draw with 1 battery only. Then switch, ammeter, bulb and rheostat will be in series. Then the voltmeter here will be parallel to the circuit lah. Okay, so series will be connection to the ammeter, then parallel will be the connection to the voltmeter here. Okay, so as I mentioned just now, if let's say we need to get the 5 MV and RV and plotting the graph, so this will be considered as a hypothesis experiment. Okay, so the last step will be draft the table for MV and RV for fill all the data. Okay, so here we need to measure current and the corresponding here will be potential difference. So you can just draft your table like this. Then you can start to connect your apparatus to finding the minimum and maximum value which is able to measure by your ammeter. In this stimulation, I'm going to show you how to get the maximum and minimum data according to the question. Okay, so now let me show you how I identify 5 MV and RV for the Tugasan Amali tidak berpandu. And in the stimulation, I also will show you how we connect the 4-terminal rheostat to our circuit. Let's see the stimulation.
Hi everyone, I'm Mr. Pei. In today's video, I'm going to discuss with you one of the compulsory experiments in syllabus Form 5, Chapter 3, Electricity, in the subtopic of 3.2, Resistance. The compulsory experiment is Experiment 3.1, to study the relationship between the current and voltage on non-ohmic conductor. So the apparatus we are going to use will be right cell holder, voltmeter, ammeter, and this time I'm using rheostat with 4 terminal, switch, bulb holder, battery or right cell, and together with connecting wire. Before the experiment, you must identify the MV, RV and CV of the experiment. And the MV of this experiment will be the current flowing to the circuit, and we are going to measure the reading of the ammeter. And the responding variable will be the voltage in the circuit, and we are going to use the voltmeter to measure the voltage of the reading. And definitely the constant variable here will be the length of the tungsten wire in the bulb, because we're using the same bulb. And in this experiment, there will be the non-guided experiment, which is the Tugasan Amali tidak berpandu. So the reading of the manipulated variable is not provided. So you need to identify first the maximum and minimum reading of the ammeter able to measure with the apparatus provided. that here there is only one right side is connected. Okay, so the current produced might be within a very small range. So firstly, you must be able to identify the minimum and maximum value able to measure by your ammeter. So to identify the maximum and minimum reading of the ammeter, firstly you need to arrange the apparatus according to the diagram. So firstly, insert your battery or dry cell into the dry cell holder. And here you can see the dry cell holder. So there is only one button at the dry cell holder, so which is represented as the negative terminal. And there are 4 buttons on the top of the dry cell holder represented as the terminal positive of the dry cell holder. So insert your battery to the first phase, which is together with the terminal negative button here. So insert your battery, and then now you may arrange your apparatus according to diagram. Firstly, we will be arrange all components in series, so they will be the size of the voltmeter. Okay, so basically, this will be the arrangement of the component in series. Okay, so we may start the connection from dry cell holder. So the positive terminal, which is at the first button, will be connecting with the connecting wire. Make sure the metal part of the contact clip connects to the metal parts of the terminal positive here. Then connects to the one of the terminal of the switch here. So as the switch is non-polar electrical component, so you may connect at the terminal you prefer to. And as we connect the connecting wire with terminal positive, so here we must connect the ammeter with positive terminal, which is the red button here. And you should choose the lower ampere reading before you go to the higher. So that means here we're using 1 ampere button here. So, and your reading will be at the bottom scale, which the maximum value showing the 1 ampere. If you're using the higher ampere reading here, which is 5 ampere here, so you will be reading the top scale in the ammeter here, where the maximum value will be 5. So here we're using 1 ampere. So connect the another side, another terminal of the switch to the connecting wire, and another end connects to the positive terminal and with lower ampere reading, which is 1 ampere here. Then next, we are going to connect another button, which is the negative terminal back color button in the ammeter with connecting wire. And another end will be connecting to the one on the side of the bulb holder. Okay, so now we have to connecting to our rheostat. Okay, so the rheostat I'm using this video will be different with the previous video. From the previous video, the total terminal at the rheostat will be 3. Okay, so for this rheostat, there will be 4. At the top, there are 2 terminals, and at the bottom side, here we have 2 terminals. So how we connecting it? Okay, so one of the connecting wire should be connect at the top. You may choose left or the right of the top of the terminal. And another contact clip should be connecting at the bottom. You may choose left or the right at the bottom side of the terminal here. Okay, because the top and bottom, each button here will be showing the changes of the length of the point or wire in the rheostat. So when the length changes, the resistance value will changes. However, if let's say you connect both contact clip at the top or both at the bottom, so there will be no changes of the length of the point wire. So there will be no any changes for the resistance and the reading of the emitter will be showing always the same. So in simply say, there will be one connecting wire will be connected at the top, and one will be connecting at the bottom. Okay, so firstly connect another side of the battery holder with the conductor clip. So another side, I connect to the top first. Okay, so another connection should be at the bottom. You may choose one of the bottom button here. So I choose here. Okay. So just now we have already connecting the battery holder with positive terminal. So now I will connect to the negative terminal. So there will be only the one button at the bottom, which is showing the negative terminal for the dry cell holder. Okay, so you can see we have successfully connect our series circuits in the diagram. So you can close the switch. So the pointer showing the deflection, that means the circuit here is connect completely. So you may adjust your rheostat. Okay, you may adjust your rheostat, and you can see the reading of the emitter here will be changes according to the resistance value. And you can see the bulb is light up. And you can see the bulb is light up, but actually it's not very bright due to the current flowing through the circuit is actually quite low. After we complete our series circuit, so now we may start connect our voltmeter, which is parallel to the bulb according to the diagram. So from the connection of the bulb, you can see at this side, which is the left side of the bulb holder, it is actually connecting to the negative terminal of the battery. So that means at the left hand side of the bulb holder here, you should connect to the negative terminal of the voltmeter, which is the back button of voltmeter. So you may choose to connect the conductor clip together with another conductor clip, or you can straight away clip at the bulb holder. And here another side will be connect to the connect to the brake button, which is the terminal negative of the emitter. So another side, which is the red color side, definitely will be positive terminal. Okay, so we'll be at another side, which is the right side of the bulb holder. You can see the connection here will be to the positive terminal of the right side. Okay, so now you can check the connection. So after we complete our connection, when the series circuit to the emitter and parallel circuit to the voltmeter, we may start to identify our first MV reading, which is able to measure by our emitter. So now let us define the phi, MV and RV for the experiment. So firstly, we need to define or get the minimum value for the emitter. Close the switch and then adjusting your rheostat to left and right to get the minimum and maximum value of the emitter. So here you may see the minimum value for the emitter will be about 0.06, and the emitter reading will be about 0.1 volt. So now we adjust our voltmeter reading to maximum. So you can see there will be about 0.16. and our voltmeter reading is at between of the segment. So the one segment represents 0.1. So here you can define as 0.6 if you using the bottom segment. If you're using the above segment, so there will be 0.7. Or you can choose at the middle where the smallest division at 0.05. So the reading here can be given as 0.65 volt. So we see that the maximum value for the ammeter which is able to measure will be 0.16, and the minimum value where we'll be able to measure by this ammeter will be, this ammeter in this circuit will be 0.07. So now we can define our 5 MV reading where we're using maximum value 0.16 minus 0.07 divide 5. So we will get about 0.02. So that means the difference between 2 and 3 will be about 0.02. So I will choose my minimum and maximum reading range is between 0.08 to 0.16. So my first MV will be 0.08, second will be 0.10, third will be 0.12, fourth will be 0.14, and the last one will be 0.16. Now let us start our measurement from our first MV reading 0.01. So adjust your rheostat, then read your ammeter. Then adjust your rheostat again to get your second MV and second RV reading. So where the second MV reading will be 0.10. So we are successfully to get 5 MV and 5 RV reading. So now the graph you should get is expected a curved line passing through a origin. So let us plot the graph together and discuss the question. That's all for my sharing.
So now let us continue our question number 1 here. So the question A, where the question asks the candidate to draw the arrangement of the apparatus, and actually just now I also already show you the arrangement of the apparatus, and you should draft the arrangement of the apparatus before you start your experiment, right? Just now as I discussed with you already. So there will be 2 circuits here. Series circuit will be connect all the electrical components besides of the voltmeter. So the voltmeter will be connecting parallel to the circuit. Okay, so the procedure will be need to including the MV and RV as per request by the question here. Okay, so now there is a question the student always asks. So we need to write the procedure in passive or active sentence. So actually the student need to write the procedure in passive sentence, just like how you write your compulsory experiment report together with your school teacher. Okay, so first mark will be, you just need to write like this now. So the circuit is connected as shown in diagram. So you have to draw a diagram and then give this first sentence. So you will get first mark. So you can see here, the red color words where I underline is actually the words which is represent in the passive sentence. Okay, so you can see here, first mark will be draw a label diagram of the apparatus setup. So it will be this one. So the second mark here will be, you need to give your first MV in the sentence together with your first RV, which is reading of the voltmeter. in this experiment. So the sentence will be like this. Okay, so the switch is closed and rheostat is adjusted until the ammeter reads I equal to 0.08 ampere. So this will be your first MV, where you identify the minimum reading which you are going to measure in your experiment. Okay, so if I say the minimum is 0.05, so you can actually give 0.06. If I say the maximum value which is able to let you get 5 different reading. Okay, so here will be the first MV, and then the voltmeter reading will be the first RV you are going to measure, and where I already teach you how to get the reading through the simulation just now. Okay, then the third mark will be given for the repeated step for your others 4 MV and RV readings. Okay, so this will be the another 4 reading which I able to get by using my apparatus. Okay, so the next here, the question B here, tabulate your data in the space provided. Okay, so first will be you need to give the quantity physics and units in your table. And this one actually I also already discussed detail in the episode 1 already. Okay, so will be same as the episode 1. Okay, so I will be the symbol you need to state in your table, I and V, which is already stated in the question. You are not allowed to change to other symbol. If I say the symbol already stated in the question. Then second will be the correct unit. So be ampere for current, volt for potential difference. Okay, then the another to take here will be primary reading with correct decimal, which is based on the sensitivity of the apparatus and then the consistency. Okay, so that means the apparatus here referring to the voltmeter and ammeter. So the sensitivity of the apparatus, you need to follow your own apparatus. Okay, so not my one. Okay, so here, primary reading need to follow the sensitivity of the apparatus, and then we need to give consistency. So which is the decimal places for the all data must be the same. That means here will be the data for current must be have the same numbers of decimal places, and the potential difference also the same. So here I am going to discuss with you how you identify the sensitivity of the ammeter. Okay, you can see for the 10 segment here, so there will be 0 to 0.2 or 0.1. Okay, so here you can see my chloride clip or connecting wire is connected to actually 1 ampere. So here we have 2 buttons, 1 ampere and 5 ampere. Okay, so the 1 ampere, you are going to read the bottom scale where the maximum value will be 1. Then the 5 ampere, the maximum value will be 5. So here, since I'm connecting to 1 ampere, so I will read the bottom scale. And from bottom scale, so the 10 segment here will be 0 to 0.2. So when we divide 10, so the smallest division here will be referred to 0.02. Okay, so and this reading will be 0.116. Okay, so this will be the reading for the last reading. You can see all the data here will be consistent with 2 decimal places. So this is what we mentioned as consistent here. And then the sensitivity, which is 2 decimal places, will be according to your apparatus. Okay, then the voltmeter. Okay, so this is a voltmeter reading. Okay, so I will be discuss also one reading here. So you can see here the ammeter, the 10 segment here will be 0 to 1. So when we divide 10, so there will be 0.1. The smallest division will be 0.1. So that means you can actually put 0.1 for your data here. Okay, as I teach you in previous video. So here, if I say you choose the smaller division 0.1, so your data can follow the segment which is below the pointer. will be 0.1 or above the pointer, which is 0.2. So here you can see my answer, I choose 0.15. So that means I using 0.1 divided by 2, because the changes of the voltage in my experiment is actually very small. So the 0.05 will have a big impact for my reading here. So I decide to use 0.1 divided by 2, which is 0.05 for my as my smallest division. Okay, so I will get my data here will be 0.15. Okay, so then there will be the second reading 0.2 and also others. So the detail how we get the data I also actually discussed in episode 1 already. Okay, so here you can see, just I mentioned, so the decimal places for the current will be always 2 decimal places. So this one will be showing consistency. So just like I already mentioned to you, so since I choose to use 2 decimal places for my potential different reading, so I need to give consistent 2 decimal places for my reading. Okay, let's say I choose 0.1, 0.2, 0.3, 0.6 will be wrong already. Okay, because this is not consistent. If I have a data here which is 2 decimal places here. Okay, and then the last here will be regarding the secondary reading with consistent decimal places. Okay, so this one I also discussed in last video already. So the second reading here referring to the data where involve the multiplication, division from your primary reading. Okay, so here our experiment here is not involve any secondary reading. Okay, so let's say you able to correct for these 4 tick, so you will be able to get full marks for this calculation. Okay, so this is all the data I get from my experiment. Okay, so then the next here C. Okay, so the question asks us to plot the graph I against V, which is a different type of the graph. Where in episode 1, the question asks to plot the graph V against I, which is quite common, where it's actually asking the same graph in textbook. So in this video, I try to change the type of the graph, and you may see what is the data analysis question will be asked in the graph of I against V here. Okay, so basically this is a reading I get through the experiment. Okay, so for plotting a graph, so as I mentioned in episode 1, so there will be 7 ticks you need to fulfill. So the first tick will be you need to give the quantity physics, which is I for y-axis in this graph, and then V will be the x-axis here. And the second will be the unit of the parameter, which will be ampere for current and volt for potential difference. So the third tick will be the uniform scale. Okay, so firstly, you need to cover your minimum and maximum reading in your scale here. So here for current will be 0.08, maximum will be 0.16. So you can see my reading here, maximum 0.16 and 0.08 is covered in the y-axis. Then for potential difference, the minimum is 0.15. So it'll be here. The maximum here will be 0.7. And your scale must be start from 0. And then with the multiple of 1, 2, 5, and 10. So you can see here 0.1, 2, 3, 4, 5. Here will be referring to multiple 1. 0.2, 0.4 will be multiple 2. So you are not allowed to give the scale here where 1 unit here represent 3, 6, 9, 12, and others, or 4, 8, 12, and so on. So this type of the scale is considered as a wrong scale, okay, which is not able to give a uniform scale when you want to plot your data later on. Here you can see the y-axis here will be 0.02 divided by 10. So the smallest box here represents 0.002. Then for x-axis, so there will be 0.1 divided 10. So the one small box here will be represented as 0.01. Okay, then next will be the size of the graph must be greater than 4 times 5. So will be 4 will be here. 5 will be here. Okay, so which is same as what we discussed in episode 1 already. Okay, and then the next here will be, you need to plot all the points correctly. So here we have 5 points. Okay, so the first point will be 0.08 and 0.15. So here the x-axis will be 0.05. So will be here. Together with 0.08. So will be here. Okay, so you need to plot, find all points correctly. Okay, so this will be the first. Then second will be 0.1 and 0.2. So 0.2 will be our y, our x-axis in this graph, together with 0.1, so will be here. Okay, so and then also the others. Okay, so you can see here, we have already successful plot 5 points here. Okay, so the next here will be, we need to plot the baseline. Okay, so the baseline here, we have 2 criteria you need to fulfill. First will be the numbers of the point above and below the line cannot more than 1. Then the distance between the line to the point cannot be more than 0.5 cm. So here will be the graph where I draw freehand. So make sure your graph is smooth line. Okay, and then passing through origin. So you can see from my graph here, so the 4 point here is actually in the line. There will be only 1 point here, which is above the line. So that means 1 above the line, 0 below the line. 1 minus 0 become 1. So we fulfill what requirement by the baseline here. Okay, so actually I can draw all the line. I can draw all the point in the line. Okay, but here is still able to fulfill the requirement by the question. Okay, so this is the graph we get from the question here where request I against V. Okay, so now let us see what is the question I'm going to ask in the graph here. Okay, so here the first question, based on your graph, determine the value V for the value of I, where is 50% from the highest value of I you use in your experiment. Show on your graph how you determine M. So what means like this? Okay, because as I mentioned, this is Amali, tidak, berpandu. So if you have the different set of the apparatus, you might have different range of the data, as I mentioned to you just now already. So you may get the lower range and higher range. So everybody will have different value. So here you need to have your highest value I first. So for my experiment, the maximum value here will be 0.16, which will be at this point. So 50% of the highest value here will be 0.16 times 50%. So it will be 0.08 ampere. So the question asking you, what is the value of V for 0.08 ampere here? So show your graph how you get the data. So 0.08 will be here, then it will be go down, it will be like this. So you need to show at the graph how you get the potential difference with the reading I, which is 50% for your highest value. So here it will be 0.08. So the answer here will be 0.15. So you will get the mark here, first mark. Okay, so here will be, as I mentioned, you need to give correct decimal place, and second will be unit. So here will be 2 decimal places, and the unit here will be volt. Okay, then the E here will be the another type of the question regarding a power, which is actually quite similar to the question asked from the episode 1. But the equation from the episode 1 is actually P equal to I square M. So here will be P equal to V square M here. Okay, so the electric power used by the bulb is given by the graph P equal to V square M, where M is the gradient of the graph. Okay, so from here, so what is the gradient of the graph? So Ohm's law, we know that the radiance will be V over I. So when we plot the graph, V against I, so the gradients represent the radiance. So how about the graph here? So here will be I over V. So that means we arrange become 1 over R. So that means the gradients for this graph will be 1 over R. And this formula, power, is actually V square over R. So will be equal to V square bracket 1 over R, which will be M for the, which will be the gradient for this graph. So that's why you need to identify the graph, the gradient of the graph, and then multiply with V square. Then you will get the answer requested by the question here. Okay, so let us go through this question. Okay, so this is a graph where we already drew just now. So, and we want to get the power. So here, just now we know already, at this point 0.08, so the volt will be 1.5. Okay, so this is a question try to ask you. So calculate the gradients when value V same as a value V in D. So just now we get already, so our V in D will be 1.5 volt. So show on the graph how you determine the M here. Okay, so you can see the M will be here. So we need to draw a triangle. Okay, what we already learned in the episode 1. So we apply here also. Okay, so you need to get your X and Y range. So this will be S, this will be Y. Okay, so you need to substitute in your formula. Okay, and then you get your answer is 0.38 with unit ampere per volt here. Then the second question here asks you to calculate the P. Okay, then using the formula provided here. So you just substitute and then you will get your data already. All your data will be referred to the data of your physics teacher who will be going to conduct the experiment together with you and the actual paper 3 exam day. Okay, so not my data, so will be follow your teacher's data. Okay, so give answer in minimum 2 decimal places with correct unit. So this is the advanced answer. Okay, so we actually already finished discuss the 15 mark question where I designed just now. Okay, so here will be the others common question which is related to my sample question here. The operational definition for the experiment can be asked. So it will be like this. So based on this experiment, state the operational definition of the non-ohmic conductor. Okay, so how we write operational definition, actually I also have show you all how to answer this type of question in my previous video. Okay, so again I teach here. So the method will be RP plus method. Okay, so this is our graph. So what is our RP? So our RP is actually volt, right? So if I say you want to identify the conductor as non-ohmic conductor, so the non-ohmic conductor will be not obey the Ohm's law. So that means the gradients will be not constant here. Okay, so however, we can, from our responding variable, which is related to voltage, so we can define the non-ohmic conductor based on our graph here, where when I against V, so the graph showing the relationship, which is I increases with V, will be for the non-ohmic conductor. So you can give your RP as what you observe in your graph. Okay, so the answer can be like this. So non-ohmic conductor is conductor that show potential difference increases with current. Okay, when electrical circuit is connected completely. So this will be the method. So from here to current here will be our RP. Okay, so this is an advice answer for the non-ohmic conductor. Okay, so here will be the prediction question might be asked related to this experiment. And this prediction we actually apply the theory from subtopic 3.3, EMF and internal resistance. Okay, so predict what happened to the reading of ammeter, voltmeter, and brightness of the bulb if one more battery is arranged in parallel to the battery in your diagram A. Okay, so our diagram A will be this. Okay, so the question asks what is the reading of the ammeter, the brightness of the bulb, together with the voltmeter when we add on one more battery parallel to your battery which is drawn in your diagram. Okay, so there will be only one battery in your diagram. So now we add parallelly. So what is the impact for reading ammeter, voltmeter, and the brightness of the bulb? Okay, so this is a theory where actually I already explained in my previous video. Okay, so this will be the theory where you can get from your textbook. Okay, so now we discuss about parallel connection for dry cell. So we focus on here. Okay, so there will be two impact, which is effective internal resistance becomes smaller, then the total EMF will remain the same. Okay, if we add our one more battery parallel to our current battery now, just like the figure here. Okay, so this is what we discussed already. Effective internal resistance will be smaller. Okay, so here we need to apply formula. This formula you learned already at your chapter 3, electricity. Okay, so the question asks you about the ammeter, so we need to know the current here. So we will arrange a formula, we get this. Okay, so from here you can see the internal, so you can see the total EMF is remain the same. Then the changes here will be the internal resistance, which becomes smaller. So when R becomes smaller, I will be increases. So we expected the ammeter reading increases because the current flow is increases. So the brightness of the bulb will be also increases now. Okay, because the brightness of the bulb will be directly proportional to the reading of the ammeter. The more current flow through, they will make the bulb light up more brighter. So this will be first mark for prediction for ammeter and the brightness of the bulb. Second mark will be the explanation. So here, first mark will be reading of ammeter increases and the bulb light up more brighter. This will be the first mark. So the reason, as I mentioned just now here, the effective internal resistance decreases, causes more current able to flow through. So the effective internal resistance decreases and more current will be able to flow through the circuit. So this will be the explanation. Okay, then the next here will be the voltmeter reading. You need to predict increase, decrease, or remain unchanged here. Okay, so we need to know. Okay, so here, as I mentioned, when we connect the battery parallel to our circuit here, okay, so here there will be two impacts. Internal resistance decreases, then the total EMF will remain the same. Okay, will remain the same. So again, we're using this formula. Okay, so now we rearrange V equal to EMF minus IR here. Okay, so the EMF will be equal, and just now we know already, the resistance will be decreases, then the current will be increases. So there will be no significant impact for the reading of IR here. So the overall voltmeter reading will be almost the same here. Okay, so the reading of the voltmeter remain unchanged will be the third mark. Reason, because the EMF remain almost the same in the circuit here. So will be the mark number 4. Okay, so this is regarding the prediction for the dry cell, which is connected in parallel, which is actually able to relate in this experiment. Okay, so the second prediction here will be, I just changed the battery connection, the battery arrangement in the, just now will be in parallel to series here. Okay, so we have to see the reading of the ammeter, voltmeter, and brightness. If I say one more battery is arranged in series to the current battery in your diagram A, so be this, then you add on one more. So this will be in series lah. So what is the impact for ammeter reading, brightness of the bulb, and the voltmeter here? Okay, so again, here we refer back to our theory. So which is here will be price are in series. So there will be two changes here. So the effective internal resistance will be increases and the EMF will be increases. Okay, so here again we apply this formula where you learned at section 3.3 already. So now firstly we discuss the current first. So we will rearrange the formula like this. Okay, so you can see both is increases. However, the value of the EMF is normally greater than the value of the internal resistance here. So both will be increases. However, the EMF impact will be greater, so that the current flow to the circuit will be greater, given the increases value of the ammeter and also the brightness of the bulb will be light up more brighter. Okay, so here will be the advice answer. So first one will be the reading of the ammeter increases, the bulb will be light up brighter. Reason, the effective EMF increases and more current will flow through. Okay, so this will be the second one. Okay, then the next will be the prediction value or reading of our voltmeter here. Okay, so here again the changes here will be these two lah, as I mentioned already just now, total EMF and effective internal resistance. Okay, so here we apply this formula again. Okay, so we rearrange our formula V equal to EMF minus IR again. So you can see these two values is actually increases. However, EMF value will be greater compared to R. Okay, so the V voltmeter reading will be increases lah. Okay, so the answer will be like this: the reading of the voltmeter increases because the EMF increases in series. Okay, effective EMF is increases in series. So will be the fourth mark. This one will be 3. Third mark. Okay, so we have already finished our part 1. Okay, which is discussion regarding the experiment with the sample question, more than 15 marks actually, where I discussed with you just now. Okay, so now we want to compare the graph between V against I and the I against V. What is the information different between these two graphs? Okay, so this is the experiment where I designed the V against I graph will be plotted. Okay, and this is the graph where you can actually refer from episode 1. Okay, then now will be the graph I against V. So you'll be referring this video. So this will be the two graphs. Okay, so here I want to emphasize where both graphs you need to draw the curved line. Okay, not a straight line at here. So it's actually the curved line where will be passing through origin. So you can see the similarity. Both is actually showing the line, showing the curved line passing through the origin, right? Okay, so what is the difference between the graph V against I and I against V? So here you can see for this graph, V against I, so the gradients actually increases. So you can draw triangle. So you can see the gradients is increases, while for the graph I against V, the gradients is actually decreases. Okay, so why both of these showing the difference for gradients here? Okay, so here will be the same data I use. Where will be the stimulation just now I show you. Okay, so there will be the graph V against I will be like this. Then I against V will be like this. Okay, so the first difference here will be the relationship. So here will be V increases with I. For the V against I graph, I increases with V will be for the graph I against V. Okay, the second will be the gradients. For the V against I is actually represent resistance. Okay, will be get through the method I showed you just now, draw a triangle. Okay, and then get the y over x, so you get resistance already. Then for graph I against V, so the gradient is actually represent 1 over R. Okay, so please remember this. And the third here, okay, so the area obey the Ohm's law. Okay, so this one will be the theory where I already discussed in episode 1. So as I mentioned in episode 1, so the tungsten coin is actually an ohmic conductor when at the low temperature. As current flow through the coin, temperature of the coin increases and the bulb will be light up. So this is how the bulb light up. Okay, so what will be happen when temperature increases? So you can see here, gradient increases with current, indicate the resistance of the filament increases with temperature. So we'll be showing by this curve very clear. So the gradients increases. Okay, because the resistance increases. So the current, the greater the current, the hotter the filament. The greater the vibration of the atom in filament, the higher the resistance. So in this condition, the temperature cannot be constant, and tungsten will be behave as non-ohmic conductor or non-ohmic character. Okay. So conclusion here will be just now I mentioned to you, gradients will be resistance for V against I, but it will be 1 over M for I against V. Okay, so ohmic conductor will be obey Ohm's law, so where the gradient showing constant. Then the non-ohmic conductor will be not obey the Ohm's law, so the gradients will be not constant. Okay, so here, where is the part showing constant? At the graph here. Okay, so M equal to constant, that means when the gradient is constant, so they will be obey the Ohm's law. So you can see from here, although the graph is drawn in curve form, but you can see at the beginning of the area, so they will be almost a straight line. Okay, so that means here from this graph, you can see the range where the ohmic characteristic so will be at 0 to 0.08. Okay, so for graph I against V, you can see here also. So both of the graph showing the same area where obey the Ohm's law. Okay, just the bottom for V against I against V will be at the top here. Okay, so you can see both the range is actually the same. Okay, so the last one will be the formula of power, just like I showed you. So for P equal to I squared R, so the formula will be related to gradients will be like this. So the M actually is R. For the graph V against I, then for the graph I against V, so can ask for this formula, V squared over R. Okay, because we know M for graph I against V will be 1 over R. Okay, so this is a difference I want to highlight between these two graphs with the same set of the data here. Okay, then we go to our last comparison. So the effect of the different range of current to the shape of the graph. Okay, so this will be comparison between the low range current. Okay, so this one is what the experiment I conducted, and this is the set of the MV with the low range current I able to get. Okay, so this one will be from the data of episode 1. Okay, then the second set of the data is actually I did few years ago. Okay, so I get the range is higher than what I doing recently. Okay, so the range will be 0.16 to 0.24. Okay, so you can see I also conducted experiment few years ago. Okay, so you can see the range of the current I get will be higher, 0.16 to 0.24, which is actually higher than the data asked from the textbook, which is in the range of 0.14 to 0.22. Okay, both using the same numbers of bulb, but produce different range of current. Okay, so why you'll get this? Okay, so actually the total EMF play an important role. Okay, so to get the different range of current or different MV where you may able to get in your experiment. Okay, so I suspect that with the low range of the current is actually due to the battery power is actually not full. Okay, but actually you can see I still able to get the data. So that means as long as you need to get the maximum and minimum value where you able to conduct with the provided apparatus, then there will be no problem. Okay, so is it cause different impact? So now let us compare the result between the low current range, which is 0.06 to 0.14, together with high current range 0.16 to 0.24 ampere here. Okay, so you can see this is basically the graph I plot. Okay, so the first you can see both of the graph, the shape is almost the same. So they are curved line which will be passing through origin. So you can see both is actually the same. Then the second, the relationship, both also showing V increases with I. Then the gradients of the graph both also showing the same actually, because this is the graph V against I. So the gradients will be represented as a resistance. Okay, so this one is related to type of the graph. So where M equal to R equal to V over I lah. Okay, so here you can see area obey the Ohm's law where N is constant. So you can see the range is about 0.010, which is here, right? As I mentioned to you, you can see the curve. They are almost constant. Okay, although we draw smoothly with free hand. So you can see finally we can still get the area where obey the Ohm's law, which is 0.1. And here you see for the high current range, so the area will be almost the same. Although I'm using the same apparatus and number, okay, at different location. Okay, so you can see I able to manage two different range of the data. So it's actually due to the power of the battery. So the power of battery might be impact your reading of emitter range. But you can see overall, the result also showing almost the same. Okay, so you don't need to worry whether your current range is low or high, as long as you are managed to get 5 MV with your minimum and maximum value. So there will be no any problem to get the almost the same result. Okay, so again, so both of the graph is able to relate to the power formula which I discussed with you in episode 1. Okay, so you may just draw any triangle at the point requested by the question and calculate the gradients of the point, which is represented as the resistance for the particular reading of the emitter. Okay, so conclusion. So the gradients for both graph is represented as the resistance. So we just need to compare the gradients of the graph so that we know where is the part will be obeying the Ohm's law. Okay, so the tungsten coin in the bulk exhibit as non-ohmic conductor and not obey the Ohm's law when temperature increases. So you can see both the graph with different range also showing same properties. Okay, so they will be obey the Ohm's law at the beginning with low temperature or low current flow. So when current flow increases, temperature increases, so they will be showing the non-ohmic characteristic. So in conclusion here, so the different range of the current will not have a significant impact to your result. Okay, so that's all for my sharing in this video. So if let's say you think that the video is benefits to you, so you may like and share my video to your friends, and you may subscribe my channel so that you may get notification for my latest video. So that's all for my sharing. Thank you everyone, and good luck to you.